So now I'm going to talk about the PV diagram experiment using the CFR engine. Now there's actually two parts of this experiment. One is to create a PV diagram. The other is to determine the peak pressure in the cylinder as a function of spark advance. So as we begin, we're going to make sure everything is set up appropriately. We've already turned on the exhaust fan. We've already turned on the water supply, cooling water to the engine. And we've already turned on the air supply, which is going to provide cooling to the pressure transducer. I've already put some fuel into tank number 2, so that's the tank we're going to utilize. The next thing I'm going to have to do is simply start up the engine and then make sure that we have the timing set appropriately. Now, before I do that, I'm going to go ahead and turn on the electronics. In this particular experiment, we're going to use the computer. And the computer is going to actually send data through our wired internet connection right to your account. So when you log on to the computer, you'll get a screen that looks like this one. Now actually, Dr. Nissenson is logged in. For some reason, my login credentials weren't working this morning. So he's on the other side of the camera, by the way. Thank you, Paul. And so his is the location of the data. Now, you don't have to do it that way. You can also bring in a USB drive, a flash drive, and just plug it in right here. However, with the potential for viruses and all that, I do not want to recommend that anybody actually use a USB. Okay, so just let it go directly into your Cal Poly engineering account. So the system is already plugged in. You'll want to make sure that the power is on. So the power strip is back there. So clearly that's on. Of course, you're going to get here and nothing's going to be on. Once that's plugged in, make sure that you see power to the monitor, that light will come on, and then you're ready to go. And then you just turn on the switch right here. You don't have to fumble with the computer itself. You wait several minutes. It's going to give you your engineering login screen. One of you in your group, or in your case, an individual, will then log in, and you'll get this particular screen. And then we're just going to go ahead and start the software. So if we come here to the left-hand side where it says ME412L CFR, just double-click that, and here we get our virtual console, if you will. Oh, wrong one. So I'm just going to maximize this, and this is the screen that you're going to see. So probably the first thing you're going to want to do is you'll select your destination for all of your data. You could turn on the engine and warm it up while all this is taking place, but because I'm recording this and it's rather loud, that's why I'm not turning on the engine right now. But you will have already turned on the engine. Nonetheless, so now you're just going to have to decide where it's going to go. Again, we're logged in under Dr. Nissenson, and I'm just going to open up his My Documents file, and I don't want to put it in. Yeah, so this is go directly into this file, and that's where the data will eventually reside. So I'm just going to do open. Actually, that's not right. Okay. So it's on My Documents. Let's see, now click open. All right, so now it's ready to go. And why don't I just call this 4120L data. Okay. Oh, there we go. So, oh, I get it. Yeah. I'm sorry, I just click on current folder. I was clicking open, which was asking me for a new folder. All right, so it's open. So that's where the data is going to end up under his documents. And then you can put in your information if you want. Me. Here is not a bad place if you want to put the date. So 1/12/21. And this is a CFR engine timing. In this particular experiment, the PV diagram experiment, it's going to be set to 15 degrees. And this is just test number 1. So I'll just put 01. And you can make a recording of this in your own notes if you would like to. So now that's pretty much ready to go. Now, what I'm going to do is I'm going to actually turn on the engine because I have to in order to demonstrate this. Again, everything else has been turned on, the air, the water, the exhaust. So let's turn this on. Let's turn on the ignition. We're already set up to tank number 2. It's suggested that you set the fuel to air ratio at about 1.2, which is where it is right now. Yeah, it's set right at 1.2. So this is what we've already seen in one of the previous videos. And then I want to make sure that we're set at 15 degrees. So we're at 13. So, like we've seen before, I'm going to just adjust this. So it's at 15 degrees. All right, so we're pretty much ready to go now. Now, I run this engine a little bit earlier this morning, so it's plenty warm. Typically, you guys would let it run for 5 or so minutes to make sure that it's operating properly, right? And now we're actually ready. So here, let's note that it's actually giving me a trace of the cylinder pressure, right? It starts near 0 and then rises up to a peak. At some point, the combustion is going to take place, and that's what gives you the peak pressure. And then we're going to come back down. So this is just a pressure time trace over a period of time. Now let's note that there's 2 time settings here. One is a long time setting, one is a short time setting. We're actually going to put it on short, which is a half a second. In a half of a second for an engine running at 600 RPM, that should give you, about 2.5 complete cycles of the engine. So that should be enough to make sure that we have a complete cycle. So here I'm going to turn this on. Make sure it's set on the short time setting. And we're actually ready to begin the recording. So it's going to record all this data. It's going to record the pressure. And one thing I might note is that for some reason today, if you look at the minimum pressure down here, it's below 0 PSIG, which is of course impossible. So there's something wrong. I'm not sure what. Something needs to be zeroed or recalibrated. For right now, I just don't have time to figure out what that is. The data that you would be provided, assuming that you're looking at this for our virtual labs during the COVID pandemic, I'll make sure that you have data that's reasonable. But nonetheless, we just click on begin recording. It actually records for that half a second time period. Actually, it's a little more than half a second. It's recording the peak pressure during this run. And this is now giving me the actual pressure versus time trace. So I'll just go through one cycle, right? This is where the intake valve opens. Here's the intake process. Here's where the intake valve closes. We'll go through compression. Right in here somewhere, combustion begins. We hit our peak pressure. We go through now the power stroke, the pressure drops, and then eventually the exhaust valve opens. There's the exhaust process, and now we're finished. So the thing we need to make sure of is that we do have at least a complete cycle, which clearly we do. Note that when you do your data analysis, you're going to essentially isolate one cycle from the beginning of the intake stroke right through the end of the exhaust stroke. Sometimes when the data recording begins, it'll actually begin like right in the middle of one particular cycle, and that's going to be no good. So let's actually do this again. If we go up to the run here, I'll click on run. I'll hit begin recording. And you can see the problem, right? For some reason, it just didn't go through a complete cycle. So I'm just going to go back up here. I'll hit run one more. Oops. Hit run one more time. Hit begin recording again. So I'm not sure why it's not giving me the full data set. Let's try it again. There we go. Sometimes the electronics don't work properly. Nonetheless, you can see again we do have a complete cycle. So what I'm going to do is I'm just going to go to my data. So I'll go back here. You can see these are the data files that have now been produced. Let's just look at the last data file. I'm going to open it up. It's actually a text file. What it's going to do is it's going to show you the time. It's going to show you the pressure in the next column. And the third column is this going to be either a 0 or a 1? There's a magnetic pickup on the flywheel, and when the magnet, which is actually epoxy next to the flywheel, passes through the electronic pickup, it's going to sense that, and it's going to give you a 1. So what we're going to do is we're going to scroll down, and we're going to look for the number 1, and here's the number 1. So this number 1 corresponds to top dead center. Now, I know for a fact that this is not the correct value, okay? At this number 1, we already have a pressure of almost 400 psi, so clearly that's top dead center right after the beginning of the combustion process, right? So that's not the beginning of our cycle. Our cycle begins at top dead center at the beginning of the intake stroke. So we're going to look for the next number 1. That number 1 should occur here, and this is going to give you a reading which should actually be close to 0. Now again, something seems to be wrong, but clearly this would be the correct value. Yeah, I don't know, maybe there's a problem with the air supply or something, I don't know. The air is on. Nonetheless, so this is actually where our cycle begins. So here, this is going to be top dead center at the beginning of the intake stroke. That's going to be actually the beginning of the cycle that you're going to analyze. And then all this data, you're basically just going to cut and paste all this data. You're going to go all the way down to not the next number 1, but that next, this number 1 is going to correspond to top dead center during combustion. You're going to go to the following number 1 over here, and this corresponds to the end of the exhaust stroke. So this looks like it's reasonable data, again, except for the calibration error we seem to have. So I would say data looks good, and we can actually move on to the second part of this experiment. So let's go back. And for the second part of the experiment, we're going to change things a little bit. First of all, we'll probably want to change this to test number 2. And for this part of the experiment, this is where we're going to be determining what the peak pressure is as a function of spark advance. Now, it should be obvious just by looking at the data right here that the peak pressure is going to vary, right? It's going to vary from cycle to cycle. You know, you're never going to have exactly the same timing or exactly the same fuel to air ratio or exactly the same flow rates. So what you want to do is you want to put this on the long duration, so that you're actually going to record about 10 peaks, and then you're going to take the average of those peak pressures. And of course, we're going to do this for a variety of spark settings. We're going to go from 40 degrees advance all the way up to 10 degrees retard in 10 degree increments. So let's do this. Why don't we set the first one at 40. And I'm going to have to go over here now and adjust the timing to 40 degrees. By the way, I've just noticed that I'm almost out of fuel. So let me go ahead and add a little more fuel here, just to make sure we don't run out. Okay. And now we'll adjust the timing. So now we want it at 40 degrees before, so we have to rotate this clockwise significantly until we get to 40. All right. So this is a spark timing you're rarely going to see on a real engine, but nonetheless, I want you to all at least understand how advancing the spark does have an impact on the cylinder pressure and thus the power that's produced. So here now, I've got it on long time duration, and I'll hit begin record again. Now you see it's not working. Before you start a new set, you actually have to go back here and hit the run button. So just again, up to the top left, hit run. Now it's running. Again, we're on long time duration. Begin recording. And you might have noticed that it's recording for 2 seconds now. It's only showing a period of that or a section of that on this scale here. but the data should be okay. So let's do that again. Minimize this window. Here you can see our new test. Let's just open it up. Here's my information, test 2, 40 degrees. And now let's make sure we have a lot of data points. So here, number 1, it shows a peak pressure of about 1160 or so. And then we should be able to go a couple tenths of a second later. And here's the other next peak. It's closer to 1170. We go to the next peak. This one's now closer to about 1180. So you can see that each peak definitely does vary. So you're just going to take all the peak values and just average them together. This one's now dropped lower, it's about 1165. But at least we see that the data is good. And it does look like a full set of data. Right? It goes all the way down to over 2 seconds. So that's what we want to see. So perfect. So let's go back here. And now we're just going to go to another operating point. And I'll just show you one more. Of course, you're going to go in 10-degree increments. You're going to adjust to 30, run it again, 20, 10, 0. And then also we're going to go to 10 degrees retard. Okay, so that's set now at 10 degrees retard. So after top center is when this spark is going to fire. And then we'll set this. We'll go back. This one we'll set at -10 for retard. We'll hit the run button. We're still on the long duration. And we're going to begin the recording. So again, it records for 2 full seconds. Now, let's just note something here. You might look at this funny dip and wonder, well, what's that all about? There must be an error. No, there is no error. Keep in mind that we're not igniting the mixture until after we're already past top dead center. So we've completely finished the compression stroke. We're now going beyond the compression stroke. The volume's increasing, the pressure's dropping, and then the combustion takes place. So that's why we get this secondary peak. But clearly, the cylinder pressure is much, much less than it was, right? You never want to ignite the mixture after top dead center. You try to ignite the mixture before top dead center so that the combustion process is complete at about top dead center when the volume's at its smallest, so you get the highest peak pressures and thus the greatest amount of power. All right, so we've recorded this. Again, let's go to the data. I guess, yeah, here's the next one. Note that they're not in time order. They're actually in numerical order. So -10 is going to come up before +40. So that's why it's actually earlier. So don't think that you lost the data. Just hunt for it. It'll be there in your file. So here's our new data set. And again, we're just going to do much the same thing. Here's our peak pressure, which is going to occur after top dead center, right? So peak pressure is about 175. We're then going to go to our next one. And again, you'll see that there's, different peak pressures. Yeah, here's the peak pressure. I'm sorry, I said 175 before. That's not right. I was looking at the first little peak, right? The first little peak is going to be about 184. It's going to drop, but then it's going to rise once combustion begins. So here the peak pressure is about 400. Our next peak pressure is going to come in a little bit different. It's about 388, et cetera, et cetera. But again, you'll look through it. You'll make sure the data looks good. And then once you're convinced it's good, then you just go back and do your new one, right? Change the timing, run it again, begin recording again. It'll record the data. And then you're done. So once you verify that all of your data is good and that it's been sent properly to your Cal Poly account, then you can finish this particular experiment. So, we're just going to shut everything down. We'll close the windows, close all these windows, and then we're essentially finished. Now, at the end of the day, sometimes we'll be running this experiment in person, numerous people running it over the course of the day. If this is the end of the day, then we'll just go ahead and completely shut everything down To turn off the computer, well, I guess it's just like any other computer, right? You'll just hit shutdown. I'm not going to do it right now. We'll log off later. So nonetheless, um, I want to note that the timing was set properly. I never mentioned it, but the cylinder head position was set to 0.6, corresponding to a 6-to-1 compression ratio and a displacement volume of 37.5 cubic inches. I probably should have mentioned that at the beginning, but I just forgot to. So nonetheless, now that we're finished, we just go ahead and shut down the engine. Ignition is going to go off. Engine is off. Now I will note that because the engine is still hot, please don't turn off the air supply to the pressure transducer. We're going to have to leave that on probably for 3 or 4 more hours. Typically what I do is I just leave it on overnight and then come back in the morning and turn it off. Or if I stay late or the lab technician is staying late, then he'll turn it off for us. But nonetheless, that is the PV diagram experiment.